Hello children, welcome to the science online class. We are meeting again through a video. Okay, what lesson we are seeing ma? Materials, metals and non-metals. Okay, in the previous direct class and in the previous videos we have learnt about the physical properties of metals and also the chemical properties of metals and non-metals. What is the reaction with the oxygen ma? Metals and non-metals will react with oxygen and form their respective metallic oxides or non-metallic oxides. And also reaction with water. Mostly metals react with water but in a very slow manner except sodium. Sodium is the very reactive metal with water. Okay, when it placed in water, it will started to burn and release more amount of heat. Okay, so that is called exothermic reaction. Okay, next reaction with acids and bases. Both metals and non-metals react with acids and bases and give out the hydrogen gas. Okay, until this we have learned, isn't it? The next one is the displacement reactions. Okay, in chemistry more type of reactions are there. Okay, we are going to see about the displacement reactions. Okay, for that they have given the activity at page number 50, activity 4.8. Okay, let us watch the activity in a video, but first I will explain that what is a displacement reaction. Okay, look at the reaction given in front of you. There is a equation, isn't it? AB plus C gives CB plus A. Okay, AB is a compound, children. AB is a compound and C is the metal, that is an element, and it will give CB plus A. What is the meaning of this reaction, ma? The C is C will displaces A. That is in the place of C there should be some metals or elements. Okay, that element will, and AB is the compound. Okay, AB is the compound, that is a combination of two metals. Now if both are reacting means C will displaces A. From AB it will displaces A and remove that A and it will place on the place of A, that is C will replace A and it will go to the A's place. Okay, this is called displacement reactions. Okay, in that if the element taken in the C is the very reactive one, then it will happen that the displacement reaction will happen. Otherwise, if C is less reactive means it won't replace any one of the compounds. Okay, so the element, that is C, should be very reactive one, then only the displacement reaction happens. Okay children, to understand this I will show a video. Watch it carefully. Let us watch the video now children. Listen it very carefully.
Studying about metals and non-metals, now we come across a very interesting reaction called displacement reaction. To understand displacement reaction, let us consider a very simple example. One day, there was a very thin boy A. He wanted to play chess. He met a girl B who had a chessboard. They both started playing and formed AB. Now, here enters a very healthy boy C. C also wants to play chess with the girl. Now, because he is very strong, he went to the AB pair and he could easily remove A from his place and forming a pair CB. So I can say that the healthy boy C could easily displace the boy A from the pair AB and formed CB, and A was removed. Now tell me, students, if the thin boy A wants to come back and play with the girl B, will he be able to displace the boy C from CB? Of course not, because A is very weak compared to C, so he cannot displace C. Similar situations happen in chemistry. Such situations are called displacement reactions. Now, in chemistry, you will be having AB, which is a compound, where A, which is written ahead, is a metal, and B, which is written behind, is a non-metal. Now, in AB, A is a very less reactive metal, a very weak metal. Now, here enters a very strong metal, C. C in chemistry we call a very reactive metal, or maybe a more reactive metal. Now, C, being more reactive, can easily displace A from its place and forming a pair CB, and A is removed. This is called displacement reaction, where a more reactive metal displaces a less reactive metal. Let us understand this displacement reaction in detail using an activity. For that, we have 3 beakers here with 50 ml of water in each beaker. We have labeled them as A, B and C. Let's consider beaker A. Here we are going to dissolve a salt called copper sulfate. Now do you see the solution color? Which color is it? It is blue in color. So copper sulfate solution is blue color. Now we are adding zinc granules to the solution. Let's keep this undisturbed for some time. Do you see that color change now? Yes, the blue color has vanished and the solution has become colorless. What could be the reason behind this? This indicates that there was a reaction taking place between zinc and copper sulfate. Let's understand this reaction using an equation. We had copper sulfate, that is CuSO4. We added zinc granules to it, that is Zn. Now here, zinc is the metal, whereas in copper sulfate, copper is the metal. Let's check which metal is more reactive. How do we know that? We know that using the reactivity series. Recall the reactivity series. In the reactivity series, do you see that zinc is above copper? What does that mean? That means that zinc is more reactive than copper. So, zinc will easily displace copper from copper sulfate and become zinc sulfate, where copper is given out. So, the entire reaction becomes copper sulfate, that is CuSO4, plus zinc. Now, when zinc displaces copper, it forms zinc sulfate, that is ZnSO4, which is a colorless solution, and copper is given out, so plus Cu. Now, the reason behind blue colored solution changing colorless was because initially it was copper sulfate solution, but because zinc displaced copper, now it is zinc sulfate solution. But then, where is the copper? The copper settles at the bottom of the solution. So finally, this is called a displacement reaction. Let us consider another example. Let us focus on beaker B now. Now in this beaker, again we are going to add the same salt, that is copper sulfate. Do you see the color? Again it is blue. Now in this blue colored copper sulfate, this time we are adding iron nails. After adding iron nails, let us keep it undisturbed for some time. And now, do you see that change? Now the color of the solution from blue has changed to green. Again, it indicates that there was a reaction taking place between iron and copper sulfate. Let us understand this again with an equation. We had copper sulfate, that is CuSO4. We added iron to it, that is Fe. Now, is iron more reactive than copper? In the reactivity series, I can see iron lying above copper. So that means I can say iron is more reactive, so it can easily displace copper, and if it displaces copper, it will form iron sulfate, that is ferrous sulfate, FeSO4, and give copper out. So that's the reason why the blue colored copper sulfate became green, because the green color is now FeSO4, that is ferrous sulfate solution. Then where is the copper this time? The copper is on the iron nails this time. So again, this was a displacement reaction. Let's continue further and see what happens in beaker C. Now in beaker C, we are going to dissolve zinc sulfate salt. So the solution is zinc sulfate. What is the color? Observe. The color is, it has no color, it is colorless. Now in this colorless zinc sulfate solution, we are adding copper turnings. After some time, do you observe any color change or any reaction happening, any changes happening in the beaker? I cannot see anything. That means we can say there was no reaction taking place here. What could be the reason behind? Let's understand again with an equation. We had zinc sulfate solution, that is ZnSO4, and we added copper to it. Now copper is a metal, whereas in zinc sulfate, zinc is a metal. Which metal is more reactive? See, in the reactivity series, we've already seen that zinc is more reactive than copper. Then if copper is less reactive, it is not being able to displace zinc from its place. So that is why there was no reaction. So what we get? We get nothing new, we get the same products, that is zinc sulfate and copper. So remember, displacement reaction is a reaction in which a more reactive metal displaces a less reactive metal. Now why don't you try finding some results of certain reactions? They are, if you have iron sulfate in a beaker, the solution, and if you add zinc to it, what will happen? And in the second one, if you have copper sulfate and you add silver to it, what will happen?
Children, I believe that you will be watch the video very carefully. Okay, in that video, and I have explained what is a displacement reaction in a very simple manner. Okay, so, and very reactive metal replaces an less reactive metal from that compound and it will occupy its place. Okay, so this is called a displacement reaction. Okay, children. Okay, next one, uses of metals. Okay, in your book they have given very shortly the metals are used in machinery, making machinery, automobiles, aeroplanes, trains, satellites, etc. We are going to see somewhat elaborate. Okay, first one, iron. Okay, iron is used for making pins, nails, nuts, bolts, tools, machines, construction of buildings, bridges, etc. Okay, it is used in a very small thing to a very bigger one. Okay, next one is the aluminum is used for making utensils, wires, furniture, parts of aircrafts, vehicles, machines, for packing food and medicines, etc. Okay, we are familiar to where in our day-to-day life we are facing many situations when we are coming to use the aluminum. Okay, next one is the copper is used for making wires, vessels, electric gadgets, etc. And the next one, gold, you will know very well. Gold is used for making jewelry, coins, medals, etc. And silver is used for making jewelry, coins, medals. Same that. Next one, platinum is used for making jewelry, electric gadgets, plugs in vehicles, etc. Okay, platinum is the most costliest metal in the world, isn't it? Next one, sodium. Sodium compounds are used as common salt. Okay, sodium chloride, which is NaCl. We are used as a salt for cooking. Okay. Next one, calcium. Calcium compounds are used for making cement, glass, etc. These are the uses of some metals, children, and there are many metals beyond this. Okay, we have seen lesser amount of metals now. Okay, next is the uses of non-metals. Okay, First one, sulfur is used for making sulfuric acid, salts and metals, etc. Okay. Next one, oxygen is used for respiration by living things burning of fuels, etc. Okay, we are inhale the air and our lungs will separate the oxygen, and we are using the oxygen for breathing and also in for breathing. And next one is the burning of fuels. Okay, if any thing is burning means it needs oxygen to burn. Okay, so oxygen is a very important thing, non-metal in the world, in our earth. Okay, next one, nitrogen. Nitrogen is used for making ammonia, which is used for making fertilizers. Okay, in the first lesson we are the lesson is crop production and management. We have seen a topic, fertilizers. In that one, fertilizers are the chemical substances. The nitrogen is the most used one in making the fertilizers. Okay, next, hydrogen is used for making ammonia, which is used for making fertilizers as fuel in rockets for welding, etc. Okay, for preparing the ammonia, the hydrogen is the very important thing. Okay, next is as fuel in rockets. Okay, rockets, the liquid hydrogen is used as a fuel. Okay, next also for welding purposes. And the next one is the chlorine is used to kill germs in water. Okay, we may feel the smell in the water sometimes. Okay, that is to clean the water. That is to purify the water. They are adding the chlorine to the water. Okay, so the smell becomes like that. Next one is the iodine. Iodine is used as tincture iodine, which is an antiseptic. Okay, for antiseptic purposes. If you hurt something at you have the wound means first you have to clean it with the antiseptic cream. Okay, in that one, iodine is the very important one. So children, we have come to the end of the lesson. Okay, but these are the they have given some uses for some metals and non-metals. There are many metals and non-metals we are using daily in our life, but we have given the few of the metals and non-metals. Okay children, up to this the lesson is over. Okay, we will meet in the next video or a direct class. You have to just read the lesson very carefully and start to learn, children. Thank you.